This video presents a method for calculating circular formulas without enabling circular references in Excel, using Lambda. Here is a frequent financial modeling problem, calculating interest expense from average debt. Average debt is the average of beginning and ending debt. Ending debt is beginning debt less cash profit. Cash profit is cash revenue minus interest expense. And we are back to where we started, interest expense. This is a circular reference. Excel will not calculate this formula unless we enable circular references. Enabling circular references in Excel can hide mistakes in calculations and slow models down. For this reason, keeping circular references in Excel disabled is considered a modeling best practice. But without circular references enabled, how can we calculate this sort of problem? One way is to use Lambda. Lambda can perform this calculation without enabling circular references. Let us see how Lambda could solve this situation. We pass three known values to the Lambda: cash revenue, beginning debt, and interest rate. The Lambda starts by calculating interest expense by multiplying average debt by the interest rate. Note: at this time, average debt is unknown and defaults to 0, which means interest expense is 0. The Lambda then calculates cash profit by subtracting interest expense from cash revenue. It then subtracts cash profit from beginning debt to determine ending debt. With ending debt and beginning debt, we calculate average debt. Using the newly computed average debt, we calculate the delta between interest expense and average debt times interest rate. If the delta is less than 0.01, our calculation is correct and we return the interest expense. If not, we repeat the entire process with a newly calculated average debt. Let's see if it works. We enter our interest expense function like any Excel function. We provide the function's arguments: cash revenue, beginning debt, and interest rate. Hit Enter. The circular reference arrows disappear, and the calculation completes. This process repeats itself. Processes that repeat themselves are known as recursive. Lambda supports recursive processing without enabling circular references. But debugging recursive processes can be tricky. Debugging is the process of removing defects from calculations. Because a Lambda is one large formula, and Excel cannot evaluate formula sections in a Lambda, I rely on two tactics to debug Lambdas. The first tactic is to cut the larger formula into a set of smaller named formulas using let. This allows us to return any section to see if it is working correctly. I use this tactic for all of my Lambdas. The second tactic is reserved for recursive Lambdas. This tactic adds parameters and tests which reveal what is happening at each repetition. The new parameters are max iterations and iteration. Max iterations is how many times the Lambda can call itself. Iteration counts how many times the Lambda has called itself. When iteration reaches max iterations, the Lambda stops. When the Lambda stops, it returns an array of every named step. Here is an example of this tactic. I place the max iterations into a row. I then place my recursive Lambda beneath that row. Then I pass max iterations to our Lambda. We can now see what happened in each repetition. On the third repetition, our Lambda has reached a result with intolerances. Now that we have solved this problem with a Lambda, we can save our Lambda and reuse it wherever we need to calculate interest expense from average debt. This is the 5G premise. We solve difficult problems once. We turn the solution into a tested, easy-to-use function. We can then use that function over and over again. And we can share our function with junior staff, so they can perform at higher levels. 5G. Quick. Correct. Easy.